Okay, for this lesson we're actually going to pull up information from the book, and we're going to, because there's a lot of graphs that use misleading statistics, and let's do the activity on this page, and this is page 648, so if you do have your math book at home you can go there, but we're going to graph the data from this table. So the table shows the results of a survey asking 100 students their favorite drink, and the choices were milk, juice, soda, and water. Now we're going to draw a bar graph, and again you're going to need graph paper. So we're going to draw a bar graph with increments of 5, and then we're going to draw a second bar graph with increments of 100, and we're going to graph this information. And we want to illustrate which graph is more likely to persuade someone that students drink too much soda. So let's take a moment and let's do our graph. Okay, so here's our graph. Again, I'm going to take a look at that data again on the book. So we're going to make our bar graph in increments of 5, first of all. So let's do that. Okay, so this is 0, and then 5, 10, 15, 20, and the biggest number is 31, so we're going to go up to 35. 20, 25, 30, and 35. We're going to go up by increments of 5. And then we have milk, juice, soda, and water. So milk, juice, soda, and water. Now, according to our data, milk is 25. So we're going to make our bar up to 25. And juice is 21, so just a little bit over 20. And soda is 31, so a little bit over 30. And water is 23, in between 20 and 25, so right there. Okay, so now let's take and just connect the lines for our bar graph, and then we're going to make a second bar graph where the increments are 10 instead of 5, but we're going to still graph the same thing: milk, juice, soda, and water. So now let's just go off the side here, and this time let's make our increments 10, and let's go like this and just extend this out, and I do want them side by side so you can get you can compare them pretty easily. So here's where our increments are going to be 10, 20, 30, and so on. And then we're going to have milk, juice, soda, and water. And again, milk was 25, so 25 is where milk is. And juice is 21, so just barely. It's hard to do it when you have the increments so close together. And soda is 31, and water is 23, so right between, a little bit less than, but right there. Now let's take and connect our lines so we have our bar graph as neat as we can make them. Okay, now the question, taking a look, is which graph is more likely to persuade someone that students drink too much soda? Well, which one shows here's our information, which one shows us where soda looks really, oopsie daisy, the soda looks really high compared to other drinks. And see, so here where our increments are more spread out, soda looks like it is definitely, you can definitely see that students drink a lot of soda. Where this one here, where the increments are only in 10 by 10s, the bars don't really differ too much from each other. So sometimes just how things are graphed will influence how people read or interpret data. So we have to kind of be careful, because sometimes statistics or graphs are misleading because they want to get a point across. So let's take a look at our page in our book again, some other examples of different misleading data. This one here is a graph that shows movie theater admissions. Now, it shows the number of admissions to movie theaters in the United States in 3 different years, 1990, 1995, and 2000. You can tell that this is old data, but nonetheless, we're paying attention to the graphing more than not the particular years. So in this year, we want to compare the admissions using this scale. So keep in mind there's a break in here from 0 to 1.1 billion. That's a big break. So it makes it 1990 seems to have about half of the number as 2000, because the bar is about half the size of the 2000 bar. But the admissions in 1990 were actually 86% of the admissions in 2000. They really aren't that different because the increments are by 0.1, 0.2, 0.3. So the big jump is from 0 to 1.1 billion. And then the increments become quite small in comparison after that. So we have to be careful about our data, where this looks like the theater admissions have increased by double. They really haven't and using this data. Now here's another one. Which line graph makes the average price of a movie ticket in the United States appear to increase more dramatically? Which one looks like it increases more dramatically or moves up quick higher? Well, this one here, the increments are in dollars, 0 increments of 1. So from 96, 97, 98, again, this is old data, but we're looking at how the data is portrayed. And it seems like if you go by each year, it kind of moves up slowly. Where now in this case, the data, there's a break in the data. Always be careful when you see a break in data. Just keep in mind that space is money, so they have to be careful of space. But sometimes you have to be careful. What are they telling us in that data? So there's a break from 0 to $4.40. So now here it makes like there was a huge, looks like there was a huge increase here in the price, because this is the price in dollars. So this is from 1996 to 1997, the price went up 20 cents. And then the next year, the price went up about 10 cents. And then from 1998 to 1999, the price went up from about $4.70 to $5, so a little over $5, so about 30 cents or so. And then from 1999 to 2000, it went from $5 to $5.40, so about 40 cents. So really over the course of time, from $4.40 to $5.40, the prices really increased $1 in that span of about 5 years. So one is definitely giving us different information than the other one. Now here we have averages. So sometimes the average can be the mean, where we add up all the data and we divide it by how many data points there are. It could be the median, the middle. We've talked about how to find mean, median, mode, or the mode, which is the most often. So here's an example of when they are using misleading averages. So again, keep in mind, this camera store owner says that the average price of a digital camera at the store is $65. And the prices of 10 digital cameras sold at this store are, and they're listed in order from smallest to largest, which is a good idea because it helps us to figure out this data. So does $65 describe the price well? They're saying they have an advertisement here that says $65 for a camera. Now that seems like a pretty good deal. But when we look at our data, the mode, they're not wrong. They're using 65 as an average, but in this case, does it give a good picture of how much cameras really cost? And here we can see definitely that there's 2 cameras that are priced at $65. The rest of the cameras are all substantially higher in price than the 2 bottom price cameras. So it does not. So they basically want to get you into the store. They're not lying by telling you that this price is $65 and that's their average, because they're using the mode for the average. But we know from looking at the rest of the data that most of the cameras cost quite a bit more, and there is a higher end camera that actually is more than double the cost of the inexpensive cameras. So now we're going to do some examples of the numbers of a monthly book donation to a library. And this is on page 649 in your book. And so our assignment is going to begin on 649 for this lesson.